This video will cover the second part of section 7.2, systems of equations in three variables. So we already solved the first one, first system, and we know we have to take two sets of equations at a time, so that we can have a 2x2 system. However, sometimes that will be a little easier for us because if you look at equation number 1, it only has two variables, right? So we're going to use that for later. Then we also have, we're going to take another set of equations, and we're kind of limited on our options now. It's not like we can take 1 and 3 or 1 and 2, because 1 does not have the variable y. So then our only option here is to take 2 and 3. And if you guys have your computer out, please close them. You should be taking notes. So I'm going to take 2 and 3. And equation number 2 is x plus y plus 2z equals 17. Equation 3 is x plus 2y plus z equals 16. So what is the variable we have to eliminate? What's the one that we don't have in equation 1? Y. So we need to eliminate y. So that tells me that I'm going to be multiplying this equation by a constant, and that constant is going to be 2, negative 2, because we want them to have opposite coefficients, right? So this 1y, we want it to be negative 2y. So we have to multiply all across, so we will have negative 2x, so we have to distribute, minus 2y, minus 2y, and then negative 2 times 2z will be negative 4z. And then negative 2 times 17 is negative 34. Equation number 3, we're not changing anything to it. And then we're going to combine like terms. So here we will get 0y. Negative 2x plus x is negative x. Negative 4z plus z is negative 3z. And negative 34 plus 16 is going to be negative 18. Okay, so that will be our equation number 4. So now what we're going to do is solve the 2x2 system. So we take equation number 1, which was given to us. And then equation number 4, that's the one that we found, negative x minus 3z is equal to negative 18. Now here we already have opposite coefficients with the x, so there's nothing that needs to be done. We don't need to multiply it. We could just cancel that out. Negative 2z is equal to negative 10. Now with that, we could find that z is negative 10 divided by negative 2. So z equals to positive 5. So we have one of the numerical values now. And it's pretty easy because now we just need to back substitute. So we're going to take equation number 1, which is x plus z equals 8. And what I'm going to do now is substitute this number, 5, for the variable z. So x plus 5 equals 8. So that means that x is equal to 8 minus 5. So x is equal to 3. Now we have two of the variables, so now we can go back to one of our original equations. And we just have to find y. So I'm going to use equation 2. So equation 2 says x plus y plus 2z equals 17. Okay, and so x we know is equal to 3. We're looking for y, and we know that z is 5. Now we just need to find y. 3 plus y plus 10 is equal to 17. So 13 plus y is equal to 17. So y is equal to 17 minus 13, so y is 4. So there you have it. We have x, y, and z. Okay. And so quickly, I'm going to tell you how to set up this system. We're not going to solve it. So we're going to use this quadratic equation here. So the y value is the output. So the output is given by this numbers here. So I can substitute the first one to create equation 1. It will be 1682 is equal to a times 4 squared. So I'm using this model right here. Substitute the x here and here. Plus b times x. So instead of x, we use 4, this number. And then plus c. Then we simplify it a little bit. 4 squared is 16. And then for number 2, the output in this case is going to be 626. And we will substitute the x with a 7. So that will be a, following this model right here, a times 7 squared. Why am I squaring it? Because that is part of the quadratic formula. Plus b times 7 plus c. After simplifying it a little bit, we will get 629 is equal to 49a plus 7b plus c. And then the third one, equation number 3 will come from here. So the y value is 967. We'll have a times the x value, which is 9, square it, plus b times 9 plus c. So simplify it.
81.
9 squared is 81, so 81a plus 9b plus c. So just quickly, what you will have, what do you guys think is the easiest variable to eliminate? C. All the coefficients are 1. So you can take equation 1 and 2, and then you could take 2 and 3, and eliminate C. Then you will find A or B, and then after that you will do substitution. So I'm gonna stay here and finish recording this one. But wait, whether you finish the video watching it or not, we're done with 7.2. Okay? All right. The homework's already for you.
What does it do? This one's here.
Okay, so I'm going to take equation number 1, which is 16 and 82 equals 16 plus 4b plus c. And then I'm going to take equation number 2 from here, but I'm going to multiply everything by -1. So all the terms will be negative, minus 626. It should be a 6. 626 is coming from here. And 626, and then we're going to have minus 49a, minus 7b, and then minus c. So then after that, that gets canceled. We have negative 3b. So after combining like terms, the constant terms, I got that. Combining the a's, I got that. So now we'll take equation number 2, which is 626, this one here. I'm going to use the negative form of it, meaning that all my coefficients are going to be negative. So negative 626 equals negative 49. So if you notice, I'm already multiplying it by -1, minus 7b minus c. And then equation number 3 would be this one here. So that would be 967 is equal to 81a plus 9b and then plus c. I don't need to multiply because here I already have opposite coefficients. So here we have plus 2b, and then we have 967 minus 626, and so that would be 341. And here we have 81 minus 49, and that would be 32. So 32a. So now we have 2 equations. We have equation number 4 right here, and equation number 5. So that's what we're going to take now. I'm going to take equation number 4, which is 1056 is equal to negative 33a minus 3b. And then we have equation number 5, which is 341 is equal to 32a plus 2b. And I'm going to go ahead and eliminate b. You can see that they already have opposite signs, but we still need to multiply them by something. So I'm going to multiply equation number 4 by the number 2. And equation number 3 by, equation number 4, I'm going to multiply by 2. And equation number 5, I'm going to multiply it by 3. Why? Because I want 3 here and 2 here, so that at the end I will have negative 6b and positive 6b. So 2 times 1056 is 2,112 is equal to negative 66a minus 6b. Now we multiply this equation, so 341 times 3, it will be 1043 is equal to 32 multiplied by 3 is 96a, and then here we will have plus 6b. So now we have equations number 4 and 5 here. Cancel that out, opposite coefficients. Here we combine like terms, so that will be positive 30a. And here on this other side, we'll have 2112 plus 1023. And that will be 3,135. So A will be whatever we get after dividing that number. And so we will get 209 over 2, and that equals to A. If we want to get a decimal approximation, we will have to press Control Enter. And so that will be approximately 104.5. Now that we have that A is equal to 104.5, we could find B by using one of the equations that are 2 by 2, either 4 or 5. And so let's say that we choose equation 5 right here. So I'm going to copy it, 341 is equal to, from here, is equal to 32a plus 2b. So if we substitute here and say 32 times 104.5 plus 2b. And so we're solving for b, so we're going to have 341 is equal to 3,344 plus 2b. So we will have 341 minus 3,344, that's equal to positive 2b. So we will get a negative 3,003. And so just to solve for b, quickly, it will be that negative 3,003 divided by 2. So then b is going to be equal to negative 1,501.5. And finally, to find c, then we could take one of the original equations, 1, 2, or 3, whatever you want. And so we could take this one here in that case. And after substituting numerical values for a and b, you will find that equation c, not equation, but the numerical value for c is actually 6,016. So now, to answer the question, which is what is the quadratic equation, then remember we started with something that was in this form, in general form, and so what we want is to use those coefficients found. So for A, we found 104.5, so 104.5 x squared. So this is the numerical value that we found. Then we also found one for b, so that would be plus, or in this case I should say minus, because b is negative, minus 1,501.5 x, and then plus the constant term, which is right here, 6,060. And so that is the quadratic function. That answers the question of the problem. Remember, we started with a table with x values here, y values here, and what we had to find was the constants a, b, and c. And this is the end of section 7.2.